Okay, so let's start. So it's, remember we have started production, we have started firm theory. And we started with the production, right? We learned about the production functions and such. Now, today we're going to also start dealing with the firm's problem. So you'll see that it's going to be very similar to consumer's problem. And the techniques and, like the way we solve it is going to be very much similar. This is what you guys have figured out in the firm theory as well. The concepts were very similar as well, right? And remember, just as we had these are special forms for utility function in consumer theory, in firm theory we had, these special functions also for the production function, right? So this is actually what we did in our last class, where we were dealing with the special production functions, and they were very similar to the utility function, as you remember. So the first one that we dealt with was perfect substitutes, right? And so perfect substitutes we were thinking of two inputs. So they were perfectly substitutable for each other, right? And we actually said that these guys, so an example could be, what could be an example? Remember we said, as perfect substitutes for inputs. For instance, it's, so let's say your mom, okay, and the coffee machine, right? Talye Arçelik's coffee machine. Or you can actually think of a person selling the Coke instead of the vending machine there, or that vending machine, right? So these are capital and labor perfectly substitutable with each other, okay? Or you can actually make a computer do all the calculations, or you can give it to a person, right? So they can also do the calculations, but of course, it's going to be, it might take for the person, for the worker to do it a longer period of time, of course. So it doesn't have to be one-to-one, but it means that they are perfectly substitutable with each other, okay? So we said that for the perfect substitutes, we would have a production function like what? It should be, just as we had in the utility theory, if they're perfect substitutes, this time now inputs, right? It should be what? Right, capital, but it should be linear. So tell me the, like the equation. We said, right, alpha L plus beta K, right? So we have alpha greater than 0, beta greater than 0, right? So this is actually the perfect substitutes where these inputs are perfect substitutes. Okay, so remember the question that I asked last time. Now you guys could figure this out. But remember we learned something called returns to scale, right? So we were wondering whether we double all the inputs, whether our output will double or not. Okay, it's going to increase proportionately, it's going to increase more than proportionately, or it's going to increase less than proportionately, right? So in this case, what do we have? So let's say that and remember it should be true for any t, it shouldn't be just doubling them, right? It should be when we multiply these inputs by any t, right, by any constant t. So we know that it should be, so for instance, the returns to scale we defined. So this is going to be what? Alpha t times L, beta t times k. So from here, when I take it into the t parentheses, this is going to be alpha L plus beta k. So this perfect substitutes case shows what? Which returns to scale? Constant returns to scale, right? Because this is exactly f of Lk, right? Whatever we said. So you see that f of t L tk equals to t times f of Lk. So we call this, therefore we said that here we see constant returns to scale. Okay. Then we had the other case, remember, it was perfect complements. So in the case of perfect complements and also for perfect substitutes, remember we said that the elasticity of substitution was what? For the perfect substitutes. It was, they're perfectly substitutable, right? So it should be high as possible, right? So it was infinity. So the correct way of saying it goes to infinity, but, right? So, and for perfect complements, are they easily substitutable? No, right? They're complements. They're not substitutable at all. So we actually, this was, in this case, remember, elasticity of substitution was 0. And in the perfect complements case, what was it? What could be an example for perfect complements? Remember, do you remember? I said, so it was the functional form, but example, right? No, but here we're production. So we have to have some labor, and we have to have a capital. What is it? Remember we said? For instance, your car and you, right? So, or a plane and 2 pilots, right? If there are 3 pilots, would they be of any use? No, not that much, right? If there's an extra driver, can they drive in your car? No, right? So it's 1 driver is enough, right? So this is basically, we said that they're perfect complements, right? So it's, and then we said that here we have, what, minimum of, how are we writing this? Alpha L, right, beta K, so the more general form, right? So let's actually say that alpha and beta are positive, okay? So let's say we have this. So here, let's try, do you think, what will happen here? Do we have increasing return scale, decreasing return scale, or constant return scale here? Okay, let's check, okay? We don't have to memorize it. Again, we say that for t greater than 1, okay, we check this, f of TL, tk, right? And then I say minimum alpha TL, beta tk, right? Whenever I see L, I write TL. Whenever I see K, I write tk, okay? Now, here we have a minimum of t times alpha L, okay, t times beta k. So can I take this t out? Minimum of 2 numbers and minimum of twice of those numbers, or 2 times the minimum of those numbers. Do you think they are the same? Same, right? So I can take this t, can get out, t times minimum alpha L beta k, okay? So you see that then we have what? Constant returns to scale, because this is exactly my original function, f of Lk, right? And this is going to be, so here we had constant returns to scale, okay? And remember, these were cases like this. So I put here K, I put here L. Perfect substitutes is a case like this, right? Perfect complements is a case like this. And we had cases in between, right? So one of them was a special one, and which is actually originated from the production theory, because it was used a lot in estimating production functions of firms, okay? So basically it was this, right? And it was a case in between. Here we have perfectly substitutability. Here they're not substitutable at all. Here they're to some extent substitutable, okay? And when this elasticity of substitution was equal to 1, we called it, this has a special name, right? It was actually called Cobb-Douglas, okay? So now the third case is Cobb-Douglas. So this is going to be, so the Cobb-Douglas, and remember these were 2 guys. So we had the Cobb-Douglas form, Cobb-Douglas production function. We had sigma goes to 1, right? So it was here, sigma was 1. And basically we had, for Cobb-Douglas, we had the form like this. Q equals to f of Lk. So we can have A times L to the power alpha, K to the power beta. Okay? So suppose A is greater than 0, alpha is greater than 0, beta is greater than 0. Okay? So what does Cobb-Douglas show? What do you think? So we'll see. Let's see. Remember, you don't have to memorize. Again, you said that, hocam, I have to check. For t greater than 1, right? F of TL, TK, let's see, it's what? It's A times TL to the power alpha, TK to the power beta. Wherever I see L, I write TL. Wherever I see K, I write TK. Okay? So then this becomes A times T to the power alpha, L to the power alpha, T to the power beta, K to the power beta. Okay? A times T to the power alpha plus beta, right? I add them up. L to the power alpha, K to the power beta. T to the power alpha plus beta, A, L to the power alpha, K to the power beta. What is this? This is my original function, right? So this is my f of L, K. This is the original function. So you see that T to the power alpha plus beta times f of Lk, f of TL, f of Tk. So what can I say here? Right, so you see, I cannot say it immediately. So it depends. As you guys said that, hocam, here it depends on alpha plus beta. So here, if alpha plus beta, okay, is greater than 1, what do we have? So we have increasing returns to scale, right? We have increasing returns to scale. If alpha plus beta is equal to 1, this is constant returns to scale, right? And the third one, if alpha plus beta is less than 1, if it's less than 1, we have decreasing returns to scale, right? So this is going to be decreasing returns to scale. So you see in the Cobb-Douglas case, it depends on the exponents, okay? Now, remember, these were all special cases of one functional form, one general functional form that we have, which was, what was it? Do you remember? CS, right? Constant elasticity of substitution form. So now in the production theory, mostly we write it like this, okay? So let's think of the fourth case as, now the fourth case was, you know, the one which was covering all these three cases, okay? So it was a CES production function, okay? So it was constant elasticity of substitution. We can write it like this, okay? And I'll tell you why. Alpha L to the power rho, beta K to the power rho. Remember, we dealt with this in consumer theory. Gamma divided by rho, where rho is less than or equal to 1, rho is not equal to 0, and gamma is greater than 0, okay? Now, this CS production function, in the one that we considered in consumer theory, we didn't have this guy, this gamma. Now let's see why we have it. In production theory, we put that extra thing there for a reason, okay? So you'll see. What do you think this will govern? What do you think this will tell us? Let's see, okay? So does this function show increasing returns to scale, decreasing returns to scale, or constant returns to scale? Let's check, right? So let's do this for any t greater than 1, okay? Or for t greater than 1, whatever you would like to write. So we have f of TL, tk, which is equal to, so wherever I see L, I write TL. So alpha TL to the power rho, beta tk to the power rho, okay? And then gamma divided by rho, okay? Now here I have alpha t to the power rho, L to the power rho, beta t to the, bless you, t to the power rho, k to the power rho, okay? To the power gamma over rho, okay? Now this is from here, if I check, so there's t to the power rho, I'm going to take this into the t to the power rho parenthesis. Alpha L to the power rho, beta K to the power rho, okay? Now, I'm going to have gamma divided by rho, okay? Now, I will have, so this rho and this will go away, T to the power gamma, right? And here, this would become alpha L to the power rho, beta K to the power rho, to the power gamma divided by rho, okay? So what is this? This is exactly my original function, right? F of Lk. And this is going to be T to the power rho. And then here I have F of TL, Tk, okay? So what is this? Do we have increasing returns to scale, decreasing returns to scale, or constant returns to scale? Again, it depends, right? As you said, hocam, it will depend on this gamma. Okay, that's why we have this in production version of it compared to the one that we have. We could have put that one in the consumer version as well, but in production, for production functions, this is there to govern the returns to scale. Okay, so just keep this in your mind. So it depends on this gamma. So we know that if that gamma is greater than 1, you said that hocam there is increasing returns to scale. If that gamma is equal to 1, there is constant returns to scale. If that gamma is less than 1, there is actually decreasing returns to scale, okay? So you see that it's important, you'll see, because a firm, they should know whether, you know, they're having an increasing returns to scale, a decreasing returns to scale, or constant returns to scale, okay? So there is, for instance, there is this, have you heard an economist called Paul Krugman? Right? So he writes in New York Times. He's a Nobel laureate. He won the Nobel Prize. So for instance, his major contribution was actually about the increasing returns to scale. So he said that, you know, for exporters, so one of the benefits of trade, right, trading between the countries, is actually if there is increasing returns to scale, firms, when they export, they can actually benefit from these scale advantages because they're going to produce more, right? Increasing returns to scale, you would see that it would mean that you are going to grow, right? You're going to have, let's say, another factory. You're going to double your inputs. You're going to double your labor. You're going to double your machinery. But the output, the resulting output, is going to be more than double, right? So if you can find some place to sell this, this is great, right? So that's why, for instance, one of the reasons to export for firms is to benefit from the scale advantages, okay? So it's very important for a firm to know, you know, you will see today that which portion. You're going to see that most of the time production functions, they don't only exhibit one of them, but they exhibit all of them, okay? So for some parts of output, there's increasing returns to scale, but after some time, there is constant returns to scale. After some time, there is decreasing because you become too big. Now the returns to scale, when you become, you know, when you grow larger and larger, the advantages will decrease, okay? So these concepts are very important. So that's why, even though I told you, you know, like to figure those out by yourselves, I just wanted to, you know, like go over them again so that you would have it in your notes, okay? And you know, these are extremely important. You'll see, okay? So basically this is, you see that, but you know, in any function, if you're given any production function, you can always show whether there is increasing returns to scale, whether there is decreasing returns to scale. For instance, at some point, Toyota's CEO, you'll see that he actually he admitted that they didn't know very well about their production function. And we're going to see also their cost function, which is going to lead to their cost function, which is going to affect their cost function. Because Toyota grew too much, and apparently they were at a point where they were decreasing returns to scale. So growing a lot was not, you know, bringing a lot of benefits, but they weren't aware of it. So you see that, shame on them. So and this is basic micro, right? So it's basic, but as I always tell you that it's very hard to estimate a firm's production function. Even if you have their capital and labor information and their output information, it's hard. You have to estimate this coefficient, and you see that it determines whether there is increasing return scale, decreasing return scale, or constant return scale. So at some point, Toyota, they become too big, and they weren't aware of it, and then they started basically losing money, okay, and they had to shrink. So they admitted that. So this is extremely important, and their CEO, he admitted that they weren't aware of the fact that growing was not very good for them, okay, because they probably, basically, you see that they weren't aware of their production function, okay. Now, so whenever you hear scale advantages, it's related to this returns to scale argument, okay? Whether growing big, whether I make my factory larger, I hire more labor, more machines, I buy more machines, is it going to bring me more output, or is it going to bring me, proportionate, a proportionate amount of increase in the output, or it's going to bring less or more, okay? More than proportionately, of course. So we'll see. You'll see why it's important. Now, we learned about the production function, okay? But remember, what was firm's aim? You guys told me that, hocam, a firm's aim is to maximize profits, right? So you said that, hocam, a firm's aim is to maximize profits. So just as people were maximizing utility, right? Consumers were maximizing utility. What about firms? Can we solve that problem? Okay? And you'll see the answer is yes. But what is profit? So first, let's actually have a look at that. Profit is what? Profit is total revenue, right? Minus total cost, right? Suppose I only have two inputs, okay? And for instance, what is my total revenue? Price times quantity, right? Suppose, let's say, usually what we know is that this price depends on quantity, right? So, but suppose the firm is a price taker, okay? So let's take the easy case, P times Q, okay? Price times quantity. And then what is the total cost? Suppose the firm has two inputs. What is total cost? Wage times labor, right? How much labor you use. Wage times L, right? And there's capital. So what is the cost of capital? We call it the rental rate, right? So we show it by R minus R times K, right? So this is total cost. That's what we call. So what is this? Q. Output, right? So it's quantity, right? So how much this firm is producing, how much this firm is selling, right? So how did we show that Q? It was our production, right? By our production function. So this is what P times this Q is F of LK. So F of LK minus wage times L minus R times K. So actually when they are maximizing profits, in a sense, they should decide on what? Labor and capital, right? Because that labor, when you decide on your labor and capital, it's going to determine your quantity, right? How much you're going to produce and sell, in this case. And then this is going to be yours, right? So this is how much labor you use. This is going to be your labor cost. This is going to be your cost of capital, right? So now, this is basically, actually you'll see that firm is going to decide on its optimal amount of profit maximizing level of capital and labor. In a sense, it will decide on its quantity, okay? But the issue is when you write down the profit, okay? You see this total revenue part, this part. This depends heavily on the market structure, okay? Remember, I said that suppose the firm is a price taker, which means that it can sell every unit at a price P, right? But is it always the case? By selling some more or less, there are cases where I can actually affect the price of the goods, right? So basically, if I sell too much, then the price is going to, right, it might decrease, right? So there could be, and that is, as I said, the more general case, this price is a function of Q, okay? So how would you decide on your quantity? How would you decide, you know, like on your how much to produce, right? How much to sell? What would be the price? These depend heavily on the market structure, okay? In this course, we're going to see the easiest, the most simple market structure where we're going to assume, you know, like it's called perfect competition, tam rekabetçi piyasa. So it's going to be, we would say that, oh, the firm is a price taker. So this is P. It's not a function of Q, okay? But it depends. It depends, you know, like think of, so do you think, like, let's think of the Arçelik, okay? Do you think for Telve coffee, Turkish coffee machines, do you think the market is a perfectly competitive market? That Arçelik is a price taker. Arçelik is just, you know, taking the price as given. No, right? So there is also, I don't know, there is, I think, Arzum, right? There are other brands, right, of these coffee machines. So it depends, right? So there could be some strategic behavior in pricing, how much, or, you know, how much to produce. It will be affected by the market, right? By the structure of the market. So what we will do for now is we're going to ignore this part, okay? So we said that suppose the firm is going to produce Q0 units, F of LK. Somehow the firm decides on its, you know, like the amount that they would like to produce, okay? Somehow. So you'll see next week, or even on Friday, we're going to come to that, okay? But suppose firm, somehow they know that they're going to produce Q0 units. Now we're going to ask this question. In order to produce this Q0 unit, what is the minimal cost? I want to produce Q0 units, but I want to spend as minimum as possible. Basically, I would like to, so let me call this my total cost, wage times L plus R times K. I would like to produce this much, but I want to do it at the minimal possible cost. So this problem, does it look familiar to you? To what? To the expenditure minimization, right? Remember, in the expenditure minimization, we asked this question. So you would like to, so let's say recall, right? Expenditure minimization. You said that there, hocam, we wanted to achieve this utility level, U of xy, let's say equals to U0 or U bar, right? And we wanted to obtain this utility level by spending the minimal amount of money, right? So it was basically, I wanted to minimize this, my expenditure, okay? So it was xy, of course, subject to this utility level. This is what the firm would like to minimize its cost, subject to this quantity. So they would like to produce this amount with the minimal amount of money, okay, with the minimal expenditure, basically. So this is called, so this is basically LK here, okay? So this problem is called cost minimization. And you'll see whatever we know about the expenditure minimization, we're going to use it here, okay? It's very easy. That's why, as I said, that this is going to go very fast because we have covered everything in the consumer theory, okay? But you see, this is cost minimization. So basically, but of course, we don't know how firm decided on that. So we'll come to that, okay? You see, because we said that that portion is related to the market structure. Whether Arçelik is the only firm or whether Arçelik is one of the 1,000 firms in that market, okay? That matters, right? So, but it's actually, that matters, but suppose it's, you know, firm knows that they would like to produce Q0 units, okay? So that's why, basically, we start not with first profit maximization, but first with cost minimization, okay? Because you see that irrespective of a market, this problem is valid everywhere, right? Whether the market is perfectly competitive, whether the market is what we call a monopoly. A monopoly is what? Right, so there's one producer, right? Tekelci piyasa. So a monopoly, or there could be oligopoly, right? So there could be, like, for instance, always we give this example, like think of the cellular phone service providers, right? You have Turkcell, Vodafone, and Avea, right? So basically, so we have an oligopoly there, okay? So you have like a few big firms. So definitely you see that depending on the market structure, this part is going to change, okay? So that's why we start with the cost minimization, because it doesn't depend on the market structure. It says that, okay, if you want to produce this amount, here is your minimal cost, and this should be your optimal capital amount of labor and capital, okay? So that's what we say. So basically, that's why we're going to start with the cost minimization first, and you'll see it's very similar to the expenditure minimization, okay? So you'll see the case. But before, let me write down some assumptions, okay? So we had some assumptions here as well. So this is going to be, the first one, we're going to assume that there are only two inputs, okay? Only two inputs, okay? Labor and capital. Of course, the extension to the AND case is immediate, okay? It's easy. So, and the other one is, actually some of your friends, they were asking me, we said labor and capital are homogeneous. Do you think this is the case in real life? Remember, these are all assumptions. But remember, we said that we should always keep them in our mind because they are simplifications of real life, right? So we said that we have homogeneous labor and capital. What does that mean? So to make these variables continuous, you can, for instance, measure the labor as labor hours, okay? Or you can just measure capital as the hours that this machine is working, okay? So you can always do it like that. But what does this mean? We have homogeneous labor and capital. Right, so it's, yes, so you are perfectly, suppose I have a factory, you're my, workers. And then it means that, you are a perfect substitute for, your friend, right? So like your labor, but do you think this is the case in real life? No, right? Some people are better workers, right? They're more productive, and some people are not that productive. So basically here we assume that every unit, each one of you, that you would have, you're similar, okay? In terms of producing stuff. So otherwise things would be hard. So the third one is, there are actually, when you write down this, there are some, also there are other costs, right? There are like what we call the entrepreneurial costs. There is someone who is bringing capital and labor together, and there is someone who wanted to start this business, right? So there are costs to that. So you could have worked at your dad's firm, but instead, let's say you're from the computer science department and you just hired two of your friends, okay? You wanted to open up a small software company. You hired two of your friends, and then you had some computers as your capital, okay? And basically, so then what's going to happen? There is some entrepreneurial cost too, because you could have worked somewhere else. But instead, you started your own firm. And basically, so these are what we are going to assume is that these entrepreneurial costs are included in this capital costs, okay? So this is basically, and do we know, so let's write this, entrepreneurial costs are in capital costs. Okay, so this is what we assume. And there's also another assumption. We assume that input markets, what we call factor markets, are perfectly competitive. So what does that mean? It means that if you want to hire some labor, if you want to hire some capital, you can hire as many as you want at a given wage and at a given rental rate, okay? By hiring more or less, you cannot affect the wage rate, for instance. Do you think it's the case for all the firms? So think of it. So we said that factor markets for labor and capital are perfectly competitive. Suppose I am, right, Ereğli Demir Çelik Fabrikası, okay? Suppose I am at Zonguldak, so for our foreign friends, so it's actually a steel factory, okay? So there is coal at this small city, Zonguldak, and basically there is actually a steel factory there. So if I hire more labor or if I hire less labor, do you think I can affect wage in that region, in that market? Mm-hmm. Right? Why? Why do you think so? Because it's the only one, right? Because if you are, like, sometimes firms can be the only buyers of a certain input there, okay? Then it matters. Then by hiring more or less, they can affect the wage, okay? So you see that all these cases this is the most simple case, but from now on in your econ classes, you're going to drop these cases, and then you're going to have these, you're going to have cases where you drop these assumptions, okay? So this is very important. So, but the one that we're going to cover here is very simple. We said that, we don't have, Ereğli Demir Çelik Fabrikası, okay? We don't have that, one steel factory which is running all the business in that region, okay? That's not going to be the case. So basically, factor markets for labor and capital are perfectly competitive. So I cannot affect the wage and R by hiring more labor or more capital, okay? Basically, I'm not the only one. It means that I'm one of the many buyers of these inputs, okay? So this is basically the case. Now, just keep this in your mind so that, under which assumptions, of course, these things are working, that we should know. But you said that, hocam, this is very similar to cost minimization. Okay, expenditure minimization. Fine. Now let's remember the expenditure minimization case. Okay. Or let's try to make the link between the cost minimization and the expenditure minimization. Okay. Now, so basically, this is what we said. So we said that irrespective of the market structure, we can concentrate on this part, sort of, and we can minimize for a given level of output, we can minimize this expenditure. So let's first solve that problem, okay? So remember, in the expenditure minimization, or graphically, what do we have? We have this. Okay, K, L. So this is, I'm going to put this. So for instance, I have this, right? So this is my isoquant. Suppose I would like to produce Q0 units. What I'm looking for is the minimal cost, right? So let's think of this. So I'm going to call this guy total cost, right? So it's like a total, it's like the budget line, but it's not the, right? It's like the expenditure, right? Total expenditure, or expenditure in the expenditure minimization. Total cost is wage times L plus R times K, okay? So what is the slope of this total cost curve? Let's call this TC. Suppose this is equal to, let's call this TC1, okay? Suppose it's equal, total cost is 5, right? So it's equal to 5. So what is this? You said that the slope of this, so we can easily figure this out. We can say R times K, total cost 1 minus wage L, right? K is equal to total cost 1 divided by R minus wage over R times L. What is the slope of this line? Minus wage over R, right? Apparently, the slope here is minus wage over R. Remember, what was the slope of the expenditure line or the budget line? Minus PX over PY, right? So very similar, okay? So do you think this is, if I spent this much, can I produce Q0? Is it enough? No, right? You said, hocam, this is not enough. You cannot achieve Q0, maybe some other output level here, right? So suppose I have, so let's call this total cost 3, okay? What is the slope of this line? Same, right? Minus wage over R, okay? So slope is again minus wage over R. So you said that, is this enough to achieve, to produce Q0? If I spent this one, it's more than enough, right? So here I can produce Q0. Here I can produce, right, by using this much capital and this much labor, or this much capital and this much labor, I can achieve, you know, like Q0 level of output. But is it just the right amount, right? Is it just the amount that is enough? You said, hocam, no, it's a bit more. You're spending more. And remember, what was the idea? In the expenditure minimization, in order to achieve that much utility, what is the minimal amount of money I should be spending? It was we should be tangent, right? So it should be some total cost line which is going through here, right? So this was the optimal, so let's call this total cost 2. Okay, so we have total cost 1 is less than total cost 2, total cost 3, okay? So basically, here we know, and how are we calling that? In the expenditure minimization, how are we calling that? Do you remember? In the expenditure minimization, so remember it was minimize, we'll do this and then we'll give a break. So PY times Y, XY, okay? And then subject to, so this is basically the utility level that you would like to achieve. Let's call it U bar, or you can call it, if you want, U0. When you solve the expenditure minimization problem, you got what? So when you solve the, actually let me put it here. So let me write it properly because it's important, okay? So let's have the expenditure minimization problem. As you said, then hocam, minimize expenditure, px times x, py times y. So xy subject to, right? You said that some given level of utility, let's call it U bar. So when we solve this problem, what did we get? Remember, this was what? The objective function, right? What is this? Constraint. And then you solve this, you got what? Right? Which demands did we get from the expenditure minimization? You call them? Compensated demands, right? So we said XC and YC, and they were functions of PX, PY, and utility, right? PX, PY, and utility. When you put these optimal guys into your objective function, remember we said that you get the value function, and we call that value function what? In the expenditure minimization. So when you plug XC here, when you plug YC here, this became expenditure function, right? And then the value function that we got here was what we call the expenditure function, and it was something like this. PX, PY, U bar, right? Which was equal to, basically, we said PX times XC, PX, PY, U bar, plus PY times YC, PX, PY, U bar, okay? So this was the expenditure function. That's what we said. Now, and these were, as you said, compensated demands. Now, these optimal guys that we will get from here, we're going to call them KC and LC, okay? And these guys would be functions of what? If you think of this, so let me write it here. Expenditure minimization. Now I'm going to have cost minimization, okay? So I'm going to have, so let me write this, minimize, as you said, hocam, cost, wage times L, R times K, okay? So LK, I write here, subject to F of LK, which is equal to Q0, okay? Or Q bar, whatever you want to call it, okay? So what is my objective function here? This guy is my objective function, right? This guy is my constraint, right? And then from here, I'm going to get, as I said, that LC, KC, which are functions of what? With similar logic. These would be functions of what? Wage, right? Price of X, price of labor, wage, price of capital, R, and Q, right? Whatever amount you would like to produce. So you can call it Q or Q0, okay? And this is wage, R, Q0. These guys are called, we call them conditional input demands, okay? Because they're conditional on this Q0 level, okay? So they're called conditional input demands. So let's call this LC, KC, wage, R, Q0, wage, R, Q0. These guys are called conditional, or your book calls them contingent. It doesn't matter, okay? Conditional input demands. Okay? Conditional demand for labor, conditional demand for capital. Okay? Because they're conditional on this output level. If you want to produce this amount of output, conditional on this amount of output, this is the optimal L and this is the optimal K that you should be using. Okay? So these are called conditional input demands. Now, when I put them back into my objective function, and then we'll give the break, we are going to call this, when I plug them in here, we're going to call this what? It's going to be called a great guess, right? It's going to be called a cost function, okay? So the value function here is going to be called cost function, okay? And then it's going to be written as, so we call it, either you call it TC or cost, total cost, which is going to be a function of what? Just as we had it here. Wage, R, and Q0, right? Or Q, whatever you want to call it. So this is basically wage times LC, wage, R, Q0, plus R times KC, wage, R, Q0, okay? So you see, because you know expenditure minimization, you actually know this. Okay, so this is basically the case.